Thank you, Travis, and thank you, ClueCon, for having me. Last year was the first time for me at ClueCon, and it's great to be back as a speaker here. So today I'm going to talk about AI in real-time communication and also how we use AI in CallStats.io. So those of you who don't know about CallStats.io is like the Google Analytics for WebRTC. We provide monitoring and analytics for WebRTC applications end-to-end. And also, we are quite active in the WebRTC community and WebRTC standard space. Our CEO, Varun, is the co-author of WebRTC Get Stats Back. So you get the point, right? So I'll just jump right in. A little bit about me. Travis already gave a glimpse of who I am, but I'll just give a brief intro. So I did my master's in communication engineering from Aalto University, Finland, the land of Nokia and Linux. And I started working with Speedy and the performance impact of Speedy in real-time network or real-time communication. That Speedy later was converted to HTTP 2.0. Also worked on the TCP initial window 10 impact on real-time communications. Then later I took up my PhD at University of Helsinki. I'm a lifetime student, I think, because I didn't really complete it. But my main focus was on transport layer optimization in machine-to-machine communication. So in early 2016, I decided to join CallStats.io as a technical account manager. And today I'm working there as a product manager. So enough about me, and let's jump in. So the vision of CallStats.io is pretty bold. So we actually envision a world where real-time communication is easy to set up, operate, and scale. Initially, many of the teleconferencing systems were integrating CallStats.io, but we have seen a lot of growth in telemedicine, online education, as well as contact centers. Recently, so many of the applications which are in the VR, AR, and mixed reality, as well as like live streaming space, has been like integrating CallStats.io. Today, we have around 800 products that have integrated CallStats.io, and also around 300 million daily active users who has been actively monitored by CallStats.io. So how's the journey of CallStats.io? In 2014, we were like collecting the metrics and aggregating it, because customers always wanted this cool dashboard where they can see like, okay, what's happening with their system? Like, okay, I have made this many calls, and how many users are happy with it, and how many calls have failed. So that was mostly like data aggregation. But 2015, we actually made a rule-based system where we were trying to find out the root cause of issues. And this is mostly based on the knowledge we had in the networking and WebRTC space. But by 2016, we already tapped out on all the rule-based systems. So there are so many rules you can have, so we need to actually innovate. So the beginning of 2017, we had so much data that we had to make that data actionable. We had to innovate in a way that the user experience should be attributed to several parameters like RTT, location, device, or whatever you can think of. So that started our 18 months journey towards like AI. So today we have like integrations with all major browsers, and we have like CPaaS vendors like Twilio and TalkBox. Then we have like SIP-based library like JS, SIP, and SIP.js, and then SFUs and MCUs. So if you would like your logo up there, then you can come and talk to me. So where is RTC today? So some of you have already been to the conference in ComCon in London. So I'll give a quick recap on like where is the state of RTC today. RTC is being used in like many fields, including VR, surveillance, and self-driving. So in virtual space now, we just saw the demo from Dan. So in virtual space or virtual reality, you can actually do pair coding. You can collaborate with people. You can start a game with another person, or you can even watch Netflix. So it's been like RTC has been growing in VR space quite rapidly. Then if you look at surveillance, earlier it was like there are thousands of hours of videos, and then a human operator has actually go through each of this video and then figure out like if there is any issue in that video or some anomaly there. And now with the help of AI, you can actually look through those videos and figure out what is going wrong. So you can actually look at like troublemakers at the airport. So I can give you an example. So I was flying here, I was checking in my bag, and then the ticketing agent was telling me like, okay, you're going to be randomly checked at the gate. And I was like, is there any particular reason? And then he was like, no, it's just a random check. Then I'm like, I'm pretty sure he was not using AI, but it was just my beard, probably. But anyway, going back. So surveillance is used in many places. And also, you can find like lost kids, or you can even, look at the unattended baggages. And also, it's used in like doorbell systems, where you can actually, most of you would have heard about the ring.com, where you can actually, have that ring.com at outside your door, and if some delivery comes in, then you can actually talk to the delivery person, even if you are inside the house or outside the house. Then there is like assisted or self-driving. So assisted or self-driving is mostly like what you call pushed by all these newcomers like Uber and Tesla, where most of the people are like, they have cars which can drive by itself. But there's been a lot of accidents because of which all of this self-driving has been pushed back a little. And most of the states are now promoting assisted driving. So imagine a situation where you're actually, let's say, in a tight spot where you have to parallel park. And if you're not very comfortable with parallel parking, you can actually make a command like, take the control over the car and parallel park for me. Or you can even outsource that to a third party or remote agent who is actually sitting somewhere, and they can take the control of your car and parallel park for you. So the possibilities in these areas with real-time communication is actually endless. So there is a distinction between AI for communications and AI in communication. So AI in communication is mostly related to all type of like conversational devices. So you can think of like Alexa, Siri, or Google Duplex. So most of them are like, let's say, can talk on behalf of you, or you can talk to them as a human, or even you can do like real-time translations. So but today's talk is mostly about AI for communication. So let's look at some real-world examples here. So bad experience. Why do bad experience happen? It's mostly because we start really bad. So it's because of some bad echo canceling algorithms, or it could be some kind of congestion control, or a bad congestion control, or it could be that you are not capable of doing any kind of HD video or something similar. So what do you do in those cases? You usually redial, but if you are already like 5 to 10 minutes into the conversation, then you might bear with that bad experience. You might not drop off. But this typically causes some kind of like customer annoyances. They will raise tickets, and then loss in revenue. If this happens to me, what I usually do, if let's say I have a bad call with Skype, I might reach out to Skype, and Skype would say like, okay, why not you contact your ISP, because they are the one who's providing the internet, and then that could be the reason. And most of the time when I talk to the ISPs, they might not even reply. They don't care because they have enough things to deal with. But if they do reply, they complain or they blame it to 3 things. One is the location. They might say like, okay, the place you are in, they don't have a good coverage. There's no good 3G or 4G coverage. Or they could say like, okay, you are using a really cheap $20 router, which doesn't really work, or your mobile doesn't, support whatever that you're doing. Or they will try to upsell your plan. So if you are on a $20 or $25 plan, they will try to upsell by, okay, let's go with the, $5 extra plan where you will get a fiber network or something similar. So that doesn't solve your problem most of the time, but still, that's the response we have. So what do bad experience actually, depend upon? So there are like 3 factors to bad experience. And they are like media quality. This can be like page load time, or like a quality of experience. Or it could be like a device, where if you are like using the device quite a lot, and then the fans start to spin and the battery is like going down. Then there could be network with a lot of components like, okay, latency or bandwidth or losses or jitter. So at a given time, most of the time you can only have like two of them. So that is a trade-off. You have to make a trade-off between that you can only have two of them at a time. So you can have a really good network and then a media quality because you are not connected to any power source, so your battery or device side is gone. Or you can have like you're connected to a power source, so you don't have to worry about the device part, but basically you can actually go down, the network quality might be really bad. So bad quality is usually attributed to the fact that most of the applications, they don't take into consideration the device or location or the network, the prevailing network conditions. So what is the optimal scenario? So it's a highly adaptive scenario where let's think like you're at home and then you're connected to a power source. You have a really good network to choose from. You can switch between like 3G or Wi-Fi. Then you can have a really good quality. But think of a scenario where you're actually on a cafe or something. So you can think of like your battery is draining out and then your network is not that good. Then you might not have a good quality. It will always be like, starting bad because of the hard coding or whatever. Like your application always starts with HD video or something similar. Then you might not be able to control that because it's already coded into the application. So what would be the solution for this? So what can you do? So one of the things you can do is like, whenever your application starts up, you can send a configuration which actually tells the application to use this set of configuration. For example, you can say, okay, this is the resolution you want to start with, or this is the bit rate that you want to start with. Oh, so this type of device does not support this particular resolution, or this bandwidth is not supported, or this carrier does not support like video. So these things can be like sent as a configuration so the applications start well, so that you don't have to go through all this kind of hassle of like, okay, you can't hear the audio or you can't see the video, so all these things. So that is exactly what at CallStats.io what we are doing. So we try to deliver a configuration which provides optimal quality consistently. It might not be the highest quality that is possible, but it will be a consistent quality that is delivered to you. So how do we make it possible? So we make it possible by gathering all the data from endpoints or SFU or MCUs. And by learning from all this data, we are able to deliver this configuration to endpoints and SFUs. So the multi-domain orchestration is possible. You can think of a situation where you're actually using a WebRTC client, and then you have a Jitsi video bridge, and everything is hosted in Amazon cloud. So there are many things you can send it. For example, for endpoint, you can say like, okay, this is the resolution you should start at. This is the starting rate you should start at. And for bridge, whenever like there is like so many participants is there on the bridge, then you can actually say like, okay, if there is more than 100 participants, then do not choose this bridge. So there are several configurations that you can adjust, but it's really hard to actually orchestrate this if like you don't have control over these elements. So next thing is about like, how do you actually ask the right questions? Because you have deployed it, you tried to fix the things, and you have control over the end-to-end system, but how do you actually ask the right questions? Because imagine a situation that you are running a service, and you have like 10 million calls that is there. So if you have 10 million calls, then every conference have at least 100 to 150 parameters that are affecting the quality. So it can be 1 billion parameters that you actually have to look through and then figure out like which parameter is actually like causing the issue. So we started with something small so that users can find out like what is going wrong. So we started with automatic diagnosis. So this, what it does is like, it gives you a summary at the end of the call. So the end of the call, you get a summary like, okay, the call was good or call was bad, And these are the participants on the call, and what all things happen to that participants. So basically, whether they rejoined the call or they had like higher setup time, how was the quality of the call. So all these things are like added to that summary. So this notification goes out to the customer, and then you're able to figure out like what went wrong. But this works all well and good for one single conference, and also it's great for analyzing like one conference. But then it's a rule-based system, right? Because you are saying like, okay, if it's above this particular threshold, then you need to say that, okay, something has gone wrong with a particular participant. But then when you're analyzing data in real time, the amount of data that you're handling is quite high. So basically, we have two approaches for collecting the data and visualizing the data. When you're collecting the data, we are actually monitoring the endpoint and all the information that is like related to it. And then we aggregate all that information to a single conference. And that conference is aggregated to multiple aggregation based on the app or service. So this aggregation can be based on several contexts. It can be based on time, like weekly, monthly, or it can be based on locations. It can be based on browser versions, or it can be based on like operating system versions. So there can be multiple aggregations or contexts are possible in collecting the data. And when we talk about like visualization, it's a top-down approach. So you're coming to your app, and then you are like looking at, okay, I want to see all the calls that's been made in the last 1 week, or I want to see all the calls that's been made in the last 3 weeks. And then you can slice and dice that data based on like all the context that you have, like location or browser or anything. Then you can go to a particular conference, and then you can also go to a particular endpoint which is causing the problem. So how do you ask the right questions? So this is like finding a needle in a haystack. If the needle is this big, yes, true, you can find it out. But if you have to really find out which element out of this 1 billion elements that are like actually impacting your service, then you need to actually use some kind of data mining and AI within that service to actually figure out what went wrong. So we built an AI which can actually do anomaly detection and trend detection, as well as like predictions. So what is like a anomaly detection? So let's assume that you're running a conferencing service. And you're running a conferencing service, and the quality is like really going down on certain days, or 1 or 2 days it went down and you don't know what happened there. So it could be related to that you released a new application version, and that kind of caused some kind of quality degradation, or something else that you never expected. So this is an anomaly, and you need to be able to detect that, okay, what actually caused that. A trend is something like it's a continuous change. So trend is something like, let's say like your RTT is steadily increasing. So you might start to investigate like, okay, why is your RTT, or round trip time, is steadily increasing? So there could be multiple reasons. So if your system is like deployed like across the globe, then they might be making more intercontinental calls than the intracontinental calls, or people are maybe having like calls with bridges rather than peer-to-peer calls. There can be like several reasons why this RTT is increasing. So you need to find that exact element, like why your RTT is increasing. Then if you go to, let's say, like predictions, so based on your past usage behavior, we are able to predict like, okay, you have been going at this rate, so your application growth is going to be 5% in the next 30 days or the next quarter. So you're able to actually provision your services better because you have a prediction from the service. But of course, there are several external factors to that your marketing, your sales, everything impacts that. But still, in terms of like whatever networking parameters are there, you will be able to figure out that. So let's look at the usage patterns of a team collaboration application. So what do you see here? So you see here appear like a sine wave, and you have to find out like what is the actual anomaly here. So if you look at with the naked eye, you might not realize like what is going wrong here, because humans are inherently bad at like identifying patterns that they don't know. So to make it easier, I'll just mark it. So you can see there are like days where the traffic is quite high. So this is the number of calls that is shown here. So there are days where traffic is quite high. So you can see that the Monday to Friday, the traffic is quite high, and the lines that are marked with blue, they are basically the weekends. So they are not making as many calls as on like weekdays. But do you see something wrong here? But apparently not. But there is an anomaly here. The anomaly is that on 29th March, or the Thursday and Friday, the traffic is going low, and the subsequent, like Monday and Tuesday, also the traffic is like low compared to previous week. So this is something that you might find it, you might not find it. If you are good at like networking and you're good at like analyzing the traffic and good with data, you might be able to find it really quickly. But otherwise, you're going to miss out on this. And this could be anything. This could be like a day where your servers had some outage, and this could be that the quality was super bad, that users are not using your service. So there could be multiple reasons behind it. So what did our AI found out about it? So our AI actually found this, that, okay, there is an issue. So basically it said like the number of conferences per day has been fluctuating since 29th of March, so you might want to check it out. So this is like a notification that comes on our dashboard towards our customers so that it's actionable. So you can actually go to the dashboard and see like, okay, there's something wrong that is going on 29th March. So what actually went wrong there? So if you click on Discover More, you get to the graph, and then you can analyze again. But who is actually the culprit here? We did some investigation, and we figured it was Easter holidays. So basically, people are having a long weekend, so they were not using the team collaboration application that often. So they had like lower traffic during like Thursday, Friday, and then the subsequent Monday and Tuesday. So this is something, this is an external factor, and Easter actually comes on different dates every year. If it was like Christmas or New Year, which is like, fixed, then you can actually train your system. But if something that keeps changing, then you might need a system that actually detects the anomalies within your WebRTC or any kind of real-time application. Now let's look at the trends. So if you look at this graph, it has the same periodicity as the previous one. You can see that on Monday to Friday, the traffic is quite high, and then on Saturday and Sunday, you are pretty much like on a lower traffic. Except for the initial bump, you don't see much of a difference here. It's the same everywhere. So is there any kind of trend that is happening here? Could you spot anything? Probably not. But our AI actually detected that there was an increasing trend where the number of calls have been increasing, and there was a decreasing trend from middle of May to middle of June at 9%. So basically, there is a 9% decrease in the number of calls in your system. So what did we actually find out using the AI? So we found out that there was a drop in traffic during Easter. There was an increasing trend, and there was a decrease in decreasing traffic. So what did we learn from all these experiments that we have been running? So we learned that we can actually have what kind of configuration that works for an endpoint. So that means like whether the endpoint should start with a higher resolution, or it should start with video or not, so things like that. And it also took into consideration what kind of routes are performant. So basically, if you have an option between 3G and Wi-Fi, should you be choosing 3G or should you be choosing Wi-Fi? And which servers can be better utilized? So since we have end-to-end monitoring, you can see like, okay, which server is loaded and which server is not loaded. So basically, you can actually redirect your traffic to that. Or if your servers are deployed in multiple domains like Amazon or GCP or Azure, then you can actually choose which cloud source you want to actually send your traffic to. Then we also looked at the AI notifications, where how and when the traffic is actually affected. So that is one part where some of the things that you might miss out while looking at the traffic, that you're actually able to see like how the traffic is affected. So what are we actually driving towards? We are driving towards self-driving networks, where endpoints need not be configured or hard-coded, where they can get the configurations automatically. And also the interfaces that are used by endpoints is not chosen on, like, it's chosen on demand rather than hard-coded, like, okay, I want to use videos, I will only work on like Wi-Fi. Or we can also control what is happening on the middle by choosing between multiple domains or between different data centers. So here, actually, we are actually closing the loop. So our main motto is to detect the issues, diagnose the issues, and then deploy fixes for it. So with the help of AI, we are able to measure accurately and then detect those issues quicker, and then infer from them so that we are able to diagnose them better, and also we are able to like deploy fixes in a controlled manner. So that brings me to the end of the presentation. Thank you. Any questions?
All right, we have a few minutes for questions. If there are any questions for him, there's one in the back. Go ahead and yell it out, and he can repeat the question for you.
Yeah. So surveillance is like, it's an always on service, right? Because it's not like, a call which is like a fixed time or something similar. So you need to be making sure that a certain optimal quality is there. So for example, the throughput is stable, or the RTT is like, similar. Because it's probably like a one-way traffic, so you don't really care about the RTT so much. And also you want to make sure that the packet loss is like lower, so that you're able to actually analyze that particular video that's being sent back to the storage. So most of them might depend on these three metrics, like throughput, RTT, or jitter, and then you might want to analyze that video later.
Big round of applause for Binoy.
Yep.